Alright, today I'm going to do physics problem number 3 on the Go problem section. So let's make ourselves familiar with this problem. The problem is, in a football game, a kicker attempts a field goal. The ball remains in contact with the kicker's foot for 0.65 seconds, during which the time it experiences an acceleration of 219 meters per second squared. The ball is launched at an angle of 59.2 degrees above the ground. Determine the horizontal and vertical components of the launch velocity. So I think the first step and the most useful step for physics all the time is to draw an image. So we know that the ball is being kicked from the ground. So I'm just going to draw a horizontal line to represent our ground. And then we have a ball on the ground that's starting from rest. And eventually we're going to kick it with some sort of velocity that we don't know. And we know this is going to be a projectile, right? Because whatever comes up goes down, right? We know that this ball is not going to just go straight into the air and stay in the air. We know it has to come down at some point. All right, and then let's put in some information that we are given. So we know the ball is kicked above the ground exactly from a 59.2 degree angle, which fits our diagram right here. We know the ball was intact with the foot for 0.065 seconds, which is time. And our acceleration was 219 meters per second squared. Now, at this point, I always ask myself, is there other information that the problem doesn't give me, but I know? And in this case, there is. There's an initial velocity of 0 meters per second. And we know that because the ball started at rest. So it wasn't moving when we started, it was just sitting there on the ground, ready to be kicked. Alright, so now we know the pieces of information, and now we need to figure out what equation to use. So up here, I wrote down the kinematic equations. We have a time, an acceleration, and initial velocity. And we know the problem says determine the horizontal and vertical components of the launch velocity. Now, if we think about this first, we don't have any components figured out of velocity. So we're probably going to want an equation that fits one of those components of our triangle. So we have a hypotenuse, we have Vy and Vx. So if we can get acceleration, time, initial velocity, and one of these velocity components, we can figure out this problem. So looking at, let's take this equation. This equation has an x displacement. Well, we don't have any displacement, so we're not going to use this equation. This equation, it has that x component of displacement. We're not going to use it. We don't have that. This one also has displacement in it. And again, we don't have any form of distance. We don't know how long this ball traveled when it was kicked. So we can't use this equation. So hopefully this equation works, right? So we've got initial velocity. We know it's 0 meters per second. We have acceleration and we have time. So we're going to use this equation right here. So let me scroll down. I'm going to write down this equation. And this will be a good start to determining our components of our horizontal and vertical components, because we'll have the hypotenuse figured out, and from there we can use the angle and trigonometry to figure out these components. So we're going to just plug in the numbers. Since initial velocity is 0.0 meters per second, we're really just saying that velocity equals acceleration times time. And we're going to plug in those numbers. And then once we put this into our calculator, we should get 14.4 meters per second. And then I'm going to write that into our diagram. I'm also going to write the angle down because I forgot to put that in. Alright. So one other thing I like to do is I like to ask myself, do these units make sense? So if we check our units, you can see here our acceleration is meters over seconds squared times seconds. The seconds will only cancel out one of those seconds because this is seconds times seconds, and we're left with meters per seconds, which is good because velocity units are meters over seconds, so that makes sense. Alright, but we don't stop here. This is the velocity if we were traveling in both the x and y direction, but we just want the components of the horizontal and vertical components. So now we rely on trigonometry. I have an angle, and I'm going to start solving first the horizontal one because that's part A. Our horizontal component is this Vx. So the only components I have is an angle, the adjacent side, and the hypotenuse, which means I have to use cosine because cosine is the adjacent, or Vx, over the hypotenuse, or V. Then I'm going to plug in these numbers and we can solve for the horizontal component. I'm going to multiply the 14.4 meters per second over to isolate Vx. And when you calculate this, you should get 7.37 meters per second. Another thing to note is that in your calculator, this should be in degrees mode, because otherwise if you put it in radians, you'll get a really wacky number that's incorrect. I can also put this piece of information into our diagram. So now we know the adjacent side, we know the angle, and we know the hypotenuse. The last part of this problem is asking for the vertical component. So I can use tangent, because tangent is opposite over adjacent with an angle. I could do that, or I could do sine, which is the angle, opposite, and the hypotenuse. In this case, I just am going to choose to use sine. So sine is going to be the opposite, Vy, over the hypotenuse, or V. Same thing as last time. Oops, not cosine, sine. I'm going to write in our data. I'm going to multiply the 14.4 meters per second times sine of 59.2 degrees to solve for our vertical component. And when we calculate this in degrees, we should get 12.4 meters per second. And that is what this problem is asking for. Now, right before I say we're done with this problem, I want to check the units of our components. Does the math make sense? Well, if we do velocity times a trigonal feature, cosine, sine, or tangent, of an angle, when we take that, there's no units to this. So it's just unitless measure times meters per second to get meters per second, which makes sense because these are all components of velocity and they should all be in meters per second. And that is this problem. Hope that helped. Have a great day.